That way they make sense. For example, when we talked about adding, subtracting, multiplying, dividing, when we did that, you're working with an equation. You were doing that to both sides of an equation. You'd have to add 2 to both sides to keep it balanced. Or you'd have to multiply both sides by 3. Or you divide both sides by -6. Whatever it was, you were keeping the equations balanced because that had to hold what's called equality. So I had you guys writing down abbreviations. Add, prop, equal. Subtract, prop, equal. For multiplying, I want you to use this. So use mult. Don't use an X, don't use a dot. It's going this way, it's a little bit more specific. And then I know we did the division with the division symbol. That's fine. We're going to do a bunch of stuff with distributive property today. I want to make sure you guys see it through. Oh, thank you. You know, would you like to erase your name? You feel good about it? Anybody else that's no longer an evil doer or a bad person or a delinquent child that wants to give me their sheet? Anyone? There's only 4 of you left that can't seem to remember one piece of paper. It's just one piece of paper I've been asking for a month for you to bring. I don't know. I have. Exactly. Don't. I don't know. Anyway, for the other 3 of you that are still enrolled in the class, that we know that you actually still go here, and we see you on a regular basis. Here's an extra one, because I know papers are really heavy, and it's really tough to remember that. Oh yeah, Mr. Murphy's been asking us for a month to turn in one measly piece of paper that is so hard to carry. And it is. I agree with you, but if paper was only portable, so if we fold it, it might. There's a will. He's just arguing because that's what he does. Anyway, back to this one. Distributive property. When you guys are using distributive property, it's never over an equal sign. So, want you to make sure you write this on here. When you abbreviate distributive property, it's just distro prop. There is no equal sign for it. There isn't. All right? You're just distributing to one set of parentheses. And lastly, I want you to put somewhere on with all the algebraic stuff. We'll come back to substitution later on, but for right now, I'm not worried about it. But I want you to put a little asterisk, like a little reminder. Yesterday, when we were doing our those algebraic proofs, we're gonna do, like I said, we're gonna do more of those today. One of the steps that we continually redid was when you combine like terms. Right? When you combine like terms or math stuff, you'll see what I mean. Your reason is always going to be simplified. Okay? When you combine like terms or your math stuff, so you added 3 to both sides, subtract 2 to both sides. When you rewrite, if you will, it's simplified. When do you use solve or solve? Solve. When it's complete, when it's done. Okay. there's always people who are like, well, isn't it kind of safe? No, not technically so. I just wanted to make sure you guys have that on there. And a lot of times with these sheets, excuse me 1 second, I'm going to come back to these pretty regularly. Say, hey, put this on here. Hey, let's reword this. Hey, let's show a picture of what something looks like. So that way, when you're looking at problems, you get a visual representation. It'll help spark a memory, if you will, jog the mind. Right? Also, then tomorrow, I'm going to introduce you guys to what are called progressions, and those will be stuff that we put in squares. I'm not the world's greatest sit down and write stuff learner, but I'm very visual. If I can visualize something, I can do it. That's why I think like YouTube videos on how to do things are awesome. You know, here's an example. This is an 80 story, not a 20 story. We have a Dyson vacuum cleaner. We got it as a wedding gift years ago. And one part on it finally broke. That part was $6 to replace. So I bought the part and started looking at it going, how in the world do you get this thing to fit? Because it's on a curve, it's on a radius, you can't snap these things together. So you go to the internet, like you do, and you find YouTube videos on how to take things apart. Well, as I'm looking at this silly little vacuum cleaner, that $6 part, it's going to take me about an hour and a half to disassemble the entire machine to replace a $6 piece. Any of you have ever replaced a headlight on a car, you kind of know what I'm going through. We had a Suburban. Suburban's headlights, you have to basically disassemble the interior wheel well, pull everything apart, and then come at this weird angle to try to get the bulb out. My wife at the time had a Jetta, a Volkswagen Jetta. You open it up, there's a cup, you unscrewed it, put your finger in there, you pulled out the bulb, pulled money. The greatest thing I've ever seen in my life. My truck, same idea. You have to disassemble the entire front end of the grill, take off the two support straps for the sides of the quarter panels, and then maybe remove the air box so you can get at where the light bulb is at. I'm telling you, ladies and gentlemen, if you don't like engineering, you don't like math, if you don't want to go to college into a big major field, there is a boatload of money to be made as a master mechanic. Seriously, there is a lot of money. My brother-in-law hated school. He hated it, but he was really good with his hands. He went to ITT Tech, and he learned how to work on cars. He graduated top of his class and was offered a scholarship for Mercedes-Benz. Mercedes-Benz put him through Mercedes-Benz school out in California for a better part of a year, all paid for it. After that, he became a master mechanic. He was like 24, 25. He was one of the youngest master mechanics in the country for Mercedes-Benz. And then they said, where would you like to work? He's like, someplace warm. They sent him to South Beach. And he was a master mechanic in Southern Florida, just working on cars. He did. Yeah, he did really well for himself. So, but the idea, yeah, he passed away. But he did really well for himself. But it was one of those things. So everybody finds their niche, and I'm telling you guys, if schooling isn't the thing, but you know you like to work with your hands, start looking at cars. There's a lot of stuff. Anyway, as I digress, excuse me. As we go back to the idea of how we work with algebra, one of the things that we were doing yesterday is that we were working with, try not to do one too crazy. I'll do this one. We, again, just started writing out what we're calling statements of reasons. So if I'm looking at one like this, I'll just rewrite it. Statements and reasons. When we did this yesterday, when I wrote down an algebraic problem in What was the reason why you wrote it down? It was, you were just saying, you were given a problem to work with. Okay. Also, yesterday you found that there were many different ways to work with equations. There were, depending upon how you saw it, which way you thought would be the easiest way to start and continue on is the way that you went. So in this one, what are you thinking, or what do you think would be the way that you would start? I would use distributive property as well. Okay. My first step after the given here was I would use distributive property. So I would show my arrows just like I always do. And I'd write out 8 plus 4x plus 10 is x. And I use distributive property. Distro prop. Again, I did not do anything to two sides of an equal sign. All I did was write it down. And I used distributive property. Now what am I going to do? What am I going to do? Add the 8 and 10? Okay. If combine like terms, if I add the 8 and the 10, I'm combining like terms, and I get 4x plus 18 is x. What did I do to the left-hand side? Simplify. I combined like terms. Really, guys, Ms. Clark, put away the phone, please. Anytime I'm cleaning or writing those out and rewriting, I'm always simplifying. Okay? Even though I added them together, I'm adding on the same side of the equation. It's not add property equal. It's just simplifying. Okay? Now you have a decision to make. Do you want to move the 4x? Do you want to move the 18? Do you want to move the x? There's a bunch of different steps you can do here. Which one of those would be the least amount of steps to solve the problem? Which one? Yeah. I would, if I wanted to do this in the least amount of steps, I would subtract the 4x to the right. Normally I'd pick on the little guy, but if I did that, and if you hear through this, you'd have to subtract the x, then you'd have to subtract the 18, and then you'd have to divide and go on. But if I just, bless you, I can alleviate, bless you, I can alleviate a couple of those steps by, in this case, working with the larger number. So when I subtract something on both sides of an equal sign, what am I using? Yeah, subtract property equal, exactly. Subtract property equal. Then when I rewrite, what am I doing? Simplifying, yeah. Okay. And lastly, what do we do? Oh, I shouldn't say lastly, but what do we do next? Divide by what? Good. We're going to divide by -3. I did that to both sides of an equal sign, so divide prop equal. And then lastly, what do I get? And what's my reason? Again, most of these types of problems, ladies and gentlemen, they're really easy. I know you guys can solve these equations. You can do that rather quickly. The reason why we use algebra to start with this type of setup is so that way you guys get accustomed to not skipping steps with the thought process. Because that's where you guys will make your mistakes when we start getting into the actual geometry proofs. We might do maybe one tomorrow. But other than that, that's where we're going. Excuse me.
But when we I feel like and then why regardless of how you got
What's that? I'm sorry?
so like A plus 4x and then you got 4x.
Yes.
What about this thing you got?
Oh, if you don't put a reason, we got to put a reason.
No, you still just
Yeah, that's what I did. Remember how I was saying, anytime that you combine like terms or you're rewriting, you're simplifying. Okay? With these, because I know that there's a bunch of different terms for it, we're gonna make it really generic and just call it simplify. As opposed to I combine like terms, as opposed to I rewrote. Let's just call it simplify. Does that make sense? Is that kind of what you're asking?
Yeah.
Because you are right, there are other terms for it. I'm just trying to make it really easy. If you want to make it more difficult, we can change the rules and everybody would get really pissed at you, but that's okay.
Yeah, as long as people like
Do you guys want to make this more difficult now?
chill on stuff.
What's that? All right, why don't you guys try this one then? Well, wrong one. Excuse me. And since I am such a nice person, I'm going to give you your first reason for free.
Oh, really? The hardest one?
You're welcome, ladies and gentlemen. You're welcome. I'm a giver, not a taker. Did you just meet you? I thought you did. Or was that you? What do you get that? It's somebody who came from this general area. You kind of rolled your eyes. That's why I thought it was. Okay. Just real quick before we get too far. If you're going to do this as your first step, you're still just going to get 5x plus 15. All you did in that scenario was the distributive property. You didn't do anything over an equal sign. It just so happened that you had it on one side and you had it on the other side. Now, if you wanted to do that in two separate steps, that's fine as well. I'm just saving some space. Yes, sir. Yeah, I have a tendency just to rewrite things in terms of x. All right. So go ahead and finish that one through.